Hi, this is question number 5 from the AQA Further Pure for January 2010 exam paper. This video is going to be split into 3 parts. The first part you're going to try the question yourself, and then I'm going to go over a hint as to how you can get the answer if you're unsure, and then finally I'm going to go over the answer to the question. So if you'd like to pause the video and have a go at the question first. Okay, in the next part of the video I'm going to give you a hint for the answer of the question. Okay, so we've got 2 transformations A and B, and we need to find the equation of the line, which is the image of y is equal to 2x plus 1 and the transformation A. So I'm looking for a point that I transform A by. Okay, so we're looking for a general point xy, and that will give us a new point which we'll call the image of x and the image of y. Now, because we know a relationship between y and x, I know that this here, y is equal to 2x plus 1, so I can stick that in. I could then see if I can carry out this transformation and then see how the image of x and the image of y are related to each other. Okay, so that would be for part A. For part B, we've got the rectangle PQRS that's got an area of 4.5 centimeters squared, and it maps onto a parallelogram PQRS under the transformation of B. We want to know what the area of that new shape is, so of what the parallelogram is. So what I need to do is I need to decide how I can find out what the area scale factor is. So what bit of information is going to tell me the area scale factor, and I can use this to get that. Okay, so for part C, we've got the transformation as a composition of B followed by A. So I need to find a matrix which represents this transformation and then give a full geometrical description of it. So to get B followed by A, we first of all need to decide which order do I need to find the product of these matrices in. Remember, the order is important when we're multiplying matrices together, so which order am I going to do that in, and then once I've multiplied out the matrix, I should end up with a new matrix, and we need to decide what that new matrix, what transformation that new matrix is carrying out, so we can give the full geometrical description of it. Okay, I'd like you to pause the video now and see if you can have a go at answering those questions. Okay, the next part of the video is going to be the full answer to each of the questions. So before I start this, I'm just going to give myself a little bit more room. Whoops. Okay, so and I started part A over here because I've written down some information already, and I know that I'm going to multiply this point by this matrix here to give me a new point, but I know that there's a relationship between the x and the y of this point here, so I'm now going to put that relationship in, because I know that if I take this transformation matrix and I times it by this here, and the relationship is the y coordinate is 2 times the x coordinate plus 1, so I'm going to put that in there. I'm going to get a new point which I'm just going to call the image of x and the image of y. Okay, so the image of x and the image of y is going to be equal to the product of this. So I'm going to write this out as a single vector. So I'm going to have 3x take away 2x take away 1 and I'm going to do this row times by this column, so that's going to be negative 5x plus 4x plus 2. And I'm just going to simplify this over here, so I've got x take away 1, and the bottom part is going to be negative x plus 2. Okay, so what I want to do is I now want to know, is there a relationship between the image of x and the image of y? Well, over here, if I now write down that the image of x is going to be equal to x take away 1, and the image of y is going to be equal to negative x plus 2. I'm now going to write this in terms, so to make x the subject. So I'm going to say, well, that means x is going to be the image of x plus 1. Plus 1. And because I know the image of y is equal to negative x plus 2, I can substitute this into here, okay, because that's what x is equal to. So I can say the image of y is going to be equal to, and I'm going to put this into here, so I've got negative image of x plus 1 plus 2. And if I now simplify this further, I can say that the image of y is going to be equal to, and I've got negative x 1 plus 1, so that's going to be 1 take away the image of x. And whoops. Okay, so we've now got the equation of the line, which is the image of y is equal to x plus 1. I'm just going to tidy up my work and then we'll move on to question B. Okay, for part B, we're told that the rectangle has area 4.5 centimeters squared, and it's mapped onto a parallelogram under this transformation here, and we want to determine the area of the new shape. So what I need to know is what the area scale factor is. So I can get the area scale factor by doing the determinant of this transformation matrix here. So I'm going to find out what the determinant of 2, 5, 5, 13 is, and that will tell me the area scale factor. Once I know the area scale factor, I can multiply it by the area to find out what the new area is. So the determinant of this is going to be 26 take away 25, which is equal to 1. So that's telling me that the area scale factor is 1, or another way of saying that is the area is invariant. The area doesn't change under this transformation matrix. So my area was 4.5 centimeters squared, so my area of PQRS, sorry, the image of PQRS is going to be also be equal to 4.5 centimeters squared. Okay, now for part C, we're given the transformation matrix, told that the transformation matrix C is made up of transformation matrix B followed by A, and I need to find a matrix that represents this first of all. So because it's B followed by A, I need to do A times by B. So I'm looking for the product of matrices A and B. So I'm looking for this product here. Okay, so if I find the product of these matrices here, I'm going to get, I'll write it out in full. So we're going to have 6 take away 5, which will be the top left hand component, and then I'm going to do row 1 times by column 2, so it's 15 take away 13, and then I've got row 2 times by column 1, so that's going to be negative 10 plus 10, and then I've got row 2 times by column 2, so it's negative 25 plus 26. Okay, so that tells me that matrix C is going to be equal to, and we've got 1, 2, 0, 1. Okay, so we have now found what transformation matrix C is. We now need to give a full geometrical description of C. Okay, so what we need to be able to spot is that we've got our leading diagonal as 1, and we've got this component of our matrix as a number that isn't 0. Okay, so this here is 2, and this one here is 0. So this tells me that this is going to be a shear, and the shear is going to be parallel to the x-axis. Okay, so the x-axis in fact will be invariant, so any points on the x-axis will stay where they are, and this shear is going to be parallel to the x-axis. If this had been 2 or 3 or 4 or something, and this would have been 0, then it would have been a shear parallel to the y-axis. Okay, in order to give our full description though, we also need to show where a point maps to. And as long as we choose a point that isn't on the x-axis, because anything on the x-axis will map back onto itself, then that will do as part of our description. So what I'm going to do is I'm going to show that 0, 1, the point 0, 1, which is a point on the y-axis, and that's going to map to, and if I multiply this by 0, 1, I'm going to get 2, 1. Okay, so that's it gives us a full geometrical description of our transformation matrix C. Okay, and we're done. So thanks for joining me, and I look forward to seeing you again next time.